in Ireland, the Canadian province of Newfoundland and Labrador, the counties of Nordland, Troms, and Finnmark in Norway, and also Iceland. Today we are following the good steam we are into when, with two new topics, namely the new frontiers: sustainable wealth and health through blue bionutraceuticals. And the second one is the whale in the room. It's about the climate change. So when it comes to blue bionutraceuticals, this is one of the really hot potatoes, and not least in Norway, and in particular northern Norway. And it can, within a few decades, become the new oil, at least for us in Norway, and also contribute to increase the export of sea-based products from us by 5 times compared with our present level. There is at the moment a tremendous amount of research and business development going on, and we hope that this development leads to more than us only being suppliers of raw materials. Of course, competence on a wide scale mixed with investment capital are crucial to achieve this. When looking at typical business structure in our communities, about 95% of the companies are small and micro companies, and this often results in buyouts in our early stage of a company's life cycle, and also this leading to both owner and capital flows away from our regions. However, to be able to utilize these potentials, there are also another huge whale in the room, and that is the climate change. We know in what direction this is going, but we of course don't know the total consequences of the climate change. We know that it affects the migratory patterns of various fish species, and that new species are entering into our territories, but we of course can gain something from that, but we can also lose other possibilities and also traditional industries. I can also add that when I took my doctor's degree at the Norwegian College of Fisheries Science at the Arctic University of Norway in Tromsø 15-20 years ago, these topics were already high on the agenda, and you could say the interest for these topics has escalated since then, and we are of course very curious to hear the later findings and developments within these fields. So by that it's time for some opening address, and we have two today. One is with us live from Iceland, is Jon Brandur Stefánsson from the Ministry of Industries and Innovation in the Department of Fisheries. And the second one is recorded and is the Norwegian, the new Minister of Fishery and Maritime Affairs from Norway. His name is Bjørnar Skjæran. So we go live first from Iceland with Jon Brandur Stefánsson.
Yes, thank you, Niels. Dear Laurentic Forum organizers, speakers, and viewers, it's a pleasure to have the opportunity to address you here today. As some of you might know, following the elections here in Iceland in September, we are still waiting for the formation of the next government and the next Minister of Fisheries. Nevertheless, on the behalf of the Ministry of Innovation and Industry, I would like to tell you in this short address about the seafood sector in Iceland from the ministry's point of view when we focus on the blue economy towards the future. The importance of the seafood sector in Iceland is well known, and the sector has demonstrated its economic value not only for the fishing communities located throughout Iceland, but also for the society, as the seafood sector is one of the main economic pillars in Iceland. The utilization of the sea is intertwined with the history and the culture of the nation. and fishing has been practiced in Iceland since the ancient times. One can say that the changes and the development of the fishing industry have been the basis for progress and economic growth. The marine environment and its utilization have, to a large extent, created the quality of life that Icelanders now enjoy. This brings us to the topic at hand in this forum, the value of the blue economy, and particularly its importance to Iceland. The topic at hand is of utmost importance to the Ministry of Innovation Industry. The question is then, how can we create the right conditions and the right structure that will allow companies to continue to generate value from the blue economy to the benefit of the nation? In the ministry's view, this requires long-term view and a stable playing field with clear rules. The regulatory framework in Iceland, with its fisheries management focus on responsible fisheries and the ITQ system, has enabled companies to take a more long-term approach, contributing to increased value. The knowledge of the sea surrounding Iceland will continue to be the prerequisite for responsible fisheries in Iceland. One example of that is the construction of a new research vessel for the Marine Freshwater Research Institute, and is an important step to strengthen the foundation for enhancing the knowledge of the sea, and therefore strengthening the foundations for continued growth of Icelandic fisheries. This is particularly important when we look at the global climate challenges ahead and how they might affect the sea and the marine environment. So this is a topic that is of particular interest in Iceland and to the ministry. The government has been increasing funding for innovation and providing more tax incentive in recent years to provide support for innovation activities in the fishing industries and other industries as well. And as Professor Agnarsson mentioned yesterday, the innovation and the collaboration between Icelandic technology companies and knowledge-based companies and the seafood sector has created the conditions which allow Icelandic seafood sector to strengthen the competitive advantage and to continuously increase value in the blue economy. The government must also ensure that the interest of Icelandic fisheries sector are protected at the international level. And this involves issues like trade in marine products and fisheries management agreements. By nurturing the strength of the Icelandic fishing sector, the utilization of fish stocks, the fisheries management system, and the collaboration between the seafood sector, technology companies, and knowledge-based companies, the value from the Icelandic seafood sector and related industries can double in the next decade. This forum on the blue economy is therefore an important venue to expand on the knowledge needed to make this possible and to create the conditions to seize and capitalize on all the opportunities in the blue economy, whether they are related to new markets, changed consumer preferences, or product development that make better use of marine resources, all to enhance the value creation in the blue economy. I wish you all the best in your discussions, and thank you for the opportunity to speak to you today. Thank you.
Yeah, we should then have video recorded by Bjørnar Skjæran, the Norwegian Minister of Fishery and Maritime Affairs.
Ladies and gentlemen, the ocean has the potential to play a larger role in the economic growth of our coastal communities. The numbers back this up. New research shows that every dollar invested in key ocean-related interventions, such as increasing sustainable seafood production, decarbonizing shipping, scaling up offshore wind power, and conserving and restoring habitats, yields $5 in return, often more. A blue boost will benefit coastal communities and make a substantial contribution to meeting carbon reduction targets. This means enhanced food security, better diets, improved air quality, greater resilience in the face of storm surges and natural disasters, and the development of more sustainable jobs in tourism and fisheries. As an Atlantic Ocean nation, Norway's commitment to a continued cooperation remains firm. Bilaterally with Atlantic nations and through the Galway and Belém treaties, and regionally through coastal cooperations such as the Laurentic Forum. Norway furthermore recognizes the importance of the regional cooperations of the OSPAR Convention for the protection of the marine environment of the Northeast Atlantic. The upcoming UN Decade of Ocean Science represents a unique opportunity to address the challenges embedded in the Sustainable Development Goals that are relevant for marine ecosystems and the blue economy. Ambitious goals are set, and a global research plan has recently been submitted to the UN General Assembly. Norway supports this plan. The need for action is just as urgent. More than ever, all of us who are engaged in coastal development need to keep up the pace in the green transitions to create new blue jobs. We must also maintain initiatives to fight pollution, to combat marine litter, to continue the implementation of measures against IUU fishing, and to continue the work to combat transnational organized crime in fisheries. Many of the initiatives to foster sustainable blue growth, however, will come from the coastal regions and from forums such as the Laurentic Forum. It is you, the coastal regions, that know the issues at stake and have the expertise and knowledge to come up with the solutions. And you are in a unique position to identify which skills are needed for the future we want. The Atlantic community have a collective opportunity and responsibility to protect and restore the health of our ocean. Let's together give a blue boost to the economy and the coastal communities while building resilience against future crises. Thank you for your attention.
Okay, we say thank you very much for the interesting and optimistic words from Iceland and Norway. And it's now time to introduce the moderator of today's two sessions. The first one is moderated by Dr. May-Britt Bolton Warberg. She is moderating the session called The New Frontiers, Sustainable Wealth and Health Through Blue Bionutraceuticals. May-Britt is the Blue Bioeconomy Program Manager at the Marine Institute in Ireland, and they are, among others, responsible for designing and implementing a national support and coordination function for the blue bioeconomy sector. And May-Britt has also been working for 12 years at the National University of Ireland in Galway and in research and lecturing roles. And she has also worked with the Irish Seafood Development Agency and South Carolina Department of Natural Resources. May-Britt holds a bachelor degree from Trinity College in Dublin within environmental science, and she has a master degree from the College of Charlton in South Carolina within marine biology. And she also earned her PhD from National University of Ireland in Galway within aquaculture. The second session of today, the one about the whale in the room, about climate change, will be moderated by Jonas R. Vidarsson, and I will come back to him when that session starts. So by that, I leave the screen to the first moderator today, and this is Dr. May-Britt Bolton Warbeck.
Thank you very much, Niels, and good afternoon, everybody. My name is May-Britt, and I'll be your moderator for this first session. We have 4 great speakers lined up for you for the first session. First, you'll hear from Jon Garðar Steingrímsson, who is the Chief Operating Officer for Genus in Iceland. Next, you will hear from Lena Kjeldstrup, who is the Cluster Manager for Biotech North in Norway. From Ireland, you will hear from Jason Hooley, who's the Chief Executive Officer of Biomarine Ingredients Ireland. And you will hear from Heather Burke, Director of the Centre for Aquaculture and Seafood Development, which is an applied research centre of Memorial University's Fisheries and Marine Institute from Newfoundland and Labrador. Just some brief housekeeping notes. Each of the speakers will have 10 minutes to give their presentations, and I'd ask them to keep as close to this time as possible in the interest of everyone's time. There will be a Q&A following the presentations. For the audience, you can use the chat function for general conversation, but we'd ask that you use the Q&A function to direct questions to the panelists. Following today's session, when you log out of the meeting or leave the meeting, there will be a short survey that pops up, and the organisers would very much appreciate some feedback on this event to help with organising future events. It's not mandatory though. And there will be a short break after the panel discussion before going into the second session. But before I pass you over to Jon, we're going to show you 2 short regional videos showcasing Newfoundland and Labrador and Northern Norway. Krista?
I am green today. I chirp with joy like a cricket song. I am gray today, gloomy and damp like a morning fog. I am orange today, loud and messy like finger paint on the wall. I am yellow today. I shine my light out like the sun. I am white today, soft and quiet like new snow. I am blue today, calm as glass and cool like the sea. I'm a rainbow today, all the colors of the world. I'm a rainbow today, all the colors of the world. I'm a rainbow today, all the colors of the world are in me. All the colors of the world.
Newfoundland and Labrador.
It's calling me like the rainbow. It's calling me like the rainbow. The rainbow. One day soon,
Thanks, Krista. Nothing like being teased with beautiful landscape photos when travel is still a bit restricted. But without further ado, I'll pass you over to Jan. Jan, the floor is yours.
Oh, thank you. Thank you for the introduction, and thank you for the opportunity to speak from Siglufjörður in Iceland. And I have this first slide, Krista. So Siglufjörður, on to the next one, is the most northern commercial town in Iceland, and in 1950 we had the number of inhabitants about 3,500, and it was the 5th largest town of approximately 230 towns in Iceland. And this is due to the herring era, an era that lasted for 100 years or so. And it meant that there was a huge amount of wealth being developed in towns like Siglufjörður. But after the disappearance of the herring in around 1968, there was a regression, and this regression left the town of Siglufjörður a little bit, I wouldn't say broken, but at least it was hindered. And in 2021, we're 23rd largest of 69. So we're getting there's a regression. The town has always had fishing and fish processing industries, now tourism for the past 10 years, but biotech, this is what I'm going to go on to next. And you can see around the island these pictures from the past. But these companies left in Siglufjörður, they were left with, for instance, shrimp processing. So they were trawlers catching shrimps, and they were producing commercialized shrimp. To the click once, Trista. And the contributing margin of the value creation was dropping down, and this is hopefully what is, or I'm not hopefully, but this is what is happening a little bit with traditional fish processing. So new paradigms had to be thought of, and there was an entrepreneur in Siglufjörður who had already seen that there was potential in these shrimp shells being wasted and just dumped into landfills or into the ocean. And this was within a material within the shrimp shells, which is chitin. And this chitin has, if you turn it into a marine health product, there's a different story in terms of value creation, and there's an increasing value creation there. Yes. And over to the next slide, please. So Genesis is founded in 2005. We have been a leading biotech company within our domain. We're founded on the medicinal properties of refined and modified chitin, and especially chitosan, which is a more refined substance of chitin. We employ around 25 people today, and what we do is that we have R&D department. We do all the quality related activities in-house. We do manufacturing. We handle all finishing aspects of the products that we make, and sell in a B2C arrangement as much as we can in order to obtain as much of the value creation possible. We have today 4 platforms, and I will go a little bit deeper into those platforms in the end. But this, when we started in 2005, there was 3 things that had to be done. first was to identify and characterize the molecules that we wanted to produce. We had to come up with analytical means to make sure and understand the variety and the mixture of these molecules and how we could do the quality controls of them, and then to manufacture these products that the molecules are based on, and of course the scale of activities needed for that. And this resulted in has resulted in a more than $30 million investment, and we are still up to date, not in we haven't had a year of profit since the founding of the company. But we have two breakthroughs, and I'll go through on next slide of over one, or the first breakthrough. And this breakthrough relies on a mechanism within the human body that is supposed to stabilize and modulate inflammation. What happens is that as we grow older, the baseline of this mechanism increases, and as well as the amplitude of this work between inflammation being built and inflammation being resolved, which is a natural process. But as we grow older, the baseline increases. But if we have a disease, inflammatory disease, then this mechanism gets out of control, and stability is lost, and it becomes unregulated. The function of the molecules that we have developed and are now creating is such that they re-stabilize and modulate this mechanism. These are called chito-oligosaccharides. In our case, we call them therapeutic chito-oligosaccharides. And they are derived from this natural chitin, and we produce them in a biotech surrounding. An interesting aspect is that they are very well tolerated within the human body, and the way they're produced means that the body cannot break them down because of the processes that we have, which are proprietary. And this means that on consumption, these molecules they enter the bloodstream unchanged. On to the next slide, please. We process from an abundant raw material source, and chitin, even though that we now use chitin made from shrimp shells, we do not necessarily have to be bound to chitin from shrimp shells, can be from other sources. And we chemically modify them, bringing them to in terms of pH, very, very high and very, very low. We then do enzymatic cleaving on them, which is another aspect that the stomach would or could do. And we then separate the molecules depending on the product platform. So we have, as I said before, we have these 4 product platforms: Benecta, Simcoes, and Bonereg, and the active pharmaceutical ingredients. And the next slide, please. Benecta is a food supplement, so this is just an over-the-counter product that has been on the market since 2016, and you see pictures there in the top left corner of the actual products. So we have 2 types of variants and different type of use applications. And the challenges that we face now is that we've done test marketing in Iceland. Currently, there's probably around 1% of the Icelandic nation that is consuming Benecta on daily basis. Then we have the next platform, which is Benecta Health, and this is a product that we have created, it is within the nutraceutical aspect or a novel food. So this is something that we've created. It's in clinical trials in Hellerup University in Denmark. And the obstacle there is that we see that the EU's approach towards consumers outweighs our need as a micro company in terms of exclusivity, for instance, and costs associated for development. And we have two product platforms, the API and a bone implant, and these are the most refined molecules. And we now have these molecules in preclinical trials. And the biggest challenge there is what we have. We need access to investment capital, which seems to be not, at least a little bit scarce on these small coastal communities, or adequate partnerships. And here just a picture of the next slide, please. This is just, of course, this is not just the company behind it, it's all these collaborators, and I thank you all for listening.
Thank you very much, Jon. That was very interesting. I'd like to pass over now to Lena Kjellstrup from Norway. Lena.
Thank you so much, Maj-Britt, and thank you to the organizers for inviting me to speak to you here today on this online conference. So I'm Lena Kjellstrup, and I'm the cluster manager for the industry cluster Biotech North, located in Tromsø in northern Norway. But our members are from the whole northern part of the country. So today I will talk to you about how to get from science to commercialization, and especially in the area of marine health products. So if I can get the next slide, please. I would like to start by saying that 6 out of 10 medicines originate from the wild on land. But the tremendous diversity of life in the ocean has proven to be a rich source of inspiration for drug discovery, with success rates for marine natural products up to 4 times higher than other naturally derived compounds. Yet the marine biodiscovery pipeline is characterized by chronic underfunding, bottlenecks, and ultimately untapped potential. But the corona pandemic has accelerated the cooperation between public and private actors. The world needs a stronger health industry and new solutions. In our oceans in the north, many of the possible answers to cancer, high blood pressure, antibiotic resistance, diabetes, diagnostic tools can be found. And there is now a momentum to take a position and accelerate this development of a marine health industry, based on our world-leading research environment in marine biotechnology and ocean knowledge. And in this crossroad between health and industry, there are double gains, where export revenues and jobs are create income, while products improve public health. Next slide, please. And in Norway and many of the countries represented here today, we have some good advantages to take lead on this. Within Northern Norway lies one of the most rich and biologically diverse natural environments in the entire world. Many of the organisms in this area have had to adapt their bodies over time to be able to survive in this harsh environment, leading to the development of cold adapt properties that can be used as basis for products and processes within various marine health industries. Along our coast, we have good access to residual raw materials from our fishing and aquaculture. We have solid research and resource management, and we invest in research cruises that maps our ocean areas. Everything they find is taken home, is categorized by the Institute of Marine Research Marbank and the University of Tromsø's research group Marbio. And this is a huge treasure chest where we can find new bioactive compounds from the marine environment. And even though we should be very impressed and very proud of our fantastic research environment, today I would like to focus on the fact that just world-leading research is not enough. If we don't strengthen our knowledge about commercialization, scaling, and the market, we will lose great opportunity for both new jobs, but also solutions in health that the world needs. Next slide. And this is what Biotech North is focusing on. Our members represent industry within pharmaceuticals, nutraceuticals, food and feed ingredients, cosmetics, medical devices, diagnostic tools, aquaculture and fisheries, combined with the university and the Institute for Applied Research. And the cluster will be a driver for the development and commercialization of high-value marine health products. Next slide. And we are not volume-orientated. We want to be value-orientated. We want more focus on the development and commercialization of high-value marine health products. But if you want to succeed in this area, we have to strengthen the bridge between academia and the industry. The results from science must be invested in and test the commercial potential so we can create new solutions and products. To develop a marine health industry, we need more market insight, more verification and infrastructure for piloting, and we have to ensure that the value chain is functional and complete at all times. And we have to increase the access to risk capital for development and scaling of this industry. In general, the commercialization of marine health products is far up in the value triangle and characterized by long-term commitment, interdisciplinarity, high capital intensity, and high risk. We have to support commercialization of high-end marine products by shortening the product development cycle and reducing the cost. And we have to ensure good conditions for the entrepreneurs. We need more people, and we need young people who want to commercialize research and create their own workplace and products that the world needs. And if we succeed in this, we can create even more good examples like Jon's and the ones I will show you now. Next slide, please. The first out is Marialis, also using the shrimp. It's our cluster member who is the world's first natural product with effect on blood pressure. Their parent company, Stella Polaris, was already established as an innovative shrimp producer with a high focus on the utilization of the raw materials. And when researchers at Nofima in Tromsø found that the peptides in the shrimp shell could influence the blood pressure, the company had both the raw material and the willingness to invest. And after years of further research and development, they launched Precardix. The supplement has been clinical tested and is approved by Health Canada and FDA in the US. And they are now launching the product in 600 pharmacies in Canada and more to come. The active ingredients in Precardix is extracted from the raw material before the residues are again turned into a shrimp powder, which is sold as a flavor enhancer. And with this, Marialis managed to both utilize and reuse the entire shrimp. Next slide. This is an example Suka, or previously known as Calanus, which is the first in the world to harvest and produce the marine copepod Calanus fimarcicus, eller rødåte, as we call it in Norwegian, to develop a new and highly bioactive form of omega-3 and feed ingredients. The company investigated the properties of the zooplankton Calanus fimarcicus and ended up with several groundbreaking products for both humans and animals. Through clinical studies, the Calanus oil shows a positive effect on both body composition, muscle mass, and heart function. The chemical composition of the oil is one of a kind, and the product belongs into an exclusive category in the nutraceutical segment. The protein that remains after the oil is extracted becomes a hydrolysate, which is used for aquaculture feed. The company harvests only a microscopic part of the largest biomass in the entire North Atlantic. Next slide. The last example I want to point out is Arctic Science Technologies, the biotechnology company Tromsø that develops and produces and sells enzymes. They have already found an enzyme from the cod liver that is now used worldwide in the COVID-19 tests, where it reduced the risk of false positive tests. Little did they know when they started many years ago that the world will be affected by this pandemic. But what they did know when they started was that our cold ocean and the organisms that live there have different properties than those who live in the warm oceans. So the cold is our advantage. We just have to use it to an even greater extent. The enzymes developed by Arctic Science Technologies are used as components in diagnostic tests, molecular research, and pharmaceutical production. And enzymes from Arctic cymes are also, as I said, used in the corona testing. At the same time, the supply components used in vaccines against the virus. The company now has about 50 employees, mainly in Tromsø, but also in Europe, US, and Asia. So last slide, to sum up. So how bright is the future? Is there an easy path from going from research to commercialization? No, absolutely not. But can we manage to get more results from research commercialized? Yes, and we have to do that. But it will require a far greater effort than what we are putting down today. As soon as the researchers have their results ready, too much market clarification is left on to the companies to unleash possible market potential. There is far too little research done on the market potential for the variety of health products. The value chains require a completely different competence than what is required to sell, for example, a container of salmon. There are also other demanding regulatory obstacles along the way that require a high level of expertise and that are crucial for the product to reach the market. And not least, the regulations regarding health claims, as Tor also mentioned, make it so that much of the research results on positive health effects has no effect, as one is not allowed to use this in the marketing. And EU is particularly demanding. This means that the distinctive quality that we have the opportunity to give our products never reaches the consumers, and one is left to compete on volume and price. So Biotechnote has pointed out that the value chain is not functional and complete, and we have to fix it. Because we sit on the solutions in the oceans that could provide us so much more than just food. But we have to stop to just pointing at this gold and endless possibilities in the oceans, because just pointing at it doesn't create any jobs or essential health products that the world needs. We must provide the entrepreneurs with tools and support so that we can create new jobs and export revenues along our coasts. Thank you very much.
Thank you, Lena, for a very interesting presentation. I'm going to jump straight in with our speaker from Ireland. Jason, the floor is yours.
Thanks, Margaret, and good afternoon, everyone. The slides come up there now shortly. Yeah, so if you can move to the first slide, please. So this afternoon, I'm going to talk briefly about 3 topics. I've got 10 minutes, so it's going to be challenging to fit in the story into 10 minutes, but I'll certainly do my best. A small bit on the next slide about our company introduction. Yeah, so basically we're a biotech company, a lot similar to what you've heard in the previous 2 speakers. Set up in 2014. I think what's different about us as a company is that we're owned by fishermen based in Ireland, out of Killybegs specifically. We've raised 30 million euro to date, and I think it's interesting and what we've heard so far to just hear people talking about access to capital, and this, while we heard Lena saying that there's potential, it's also a very long and expensive journey, and that access to capital and keeping companies alive really is absolutely critical. And I think that's no different to any biotech. And I think at times maybe collectively we tend to look at this as seafood. It's not traditional seafood. It's much, much different. And the life cycle and the journey that companies have to undertake is significantly different. We started in 2014, started producing in 2017, and now we're scaling up. We've doubled revenue every year since we started, and we've now got plans to scale again. Our pipeline is full for the remainder of 2021 and for the majority of 2022. Mostly, I think, sorry, if we move to the next slide. Yeah, so mostly it's a raw material called blue whiting. For people not familiar, everyone, I think Norway and Iceland will be familiar, in Ireland with blue whiting as a stock that's traditionally used in fish meal. And what we're trying to do is take that high value protein that we consider to be high value protein and transform it into applications and powders that wouldn't be traditionally seen by using a process of enzymatic hydrolysis. We don't produce finished products, so we don't sell anything directly to the consumer. We position ourselves in terms of a point between the raw material, the catchers, and the end market. We provide powders, protein powders and mineral powders to ingredient manufacturers who will then incorporate it into their formulations. And we think that positioning of ourselves in the supply chain is really, really important. And it's a very distinct positioning because it means that we don't have to focus on end consumer needs this directly. We don't have the same high marketing costs, but we have to identify what those manufacturers want from an ingredient formulation perspective and satisfy those requirements. That takes time, but once you get into that business, into that recipe, that formulation, it's what's called, I think what we say is it's sticky. You're in there for some time, and that's particularly important. Next slide, please. So we brand our 4 main products. And I think part of the evolution here and what's probably different than the normal is our 2 biggest selling products this year didn't exist 12 months ago. So it's a constant evolution. It's trying to respond to what is it your customer requires. And your initial discussions will center around what you can produce for them, as opposed to what specifically do they want, what do they need in terms of their ingredient. Pro-Atlantic is our primary product. It's a 90% protein. So it's an isolate in ingredient terms. It's greater than 90% protein, less than 0.5% fat. And we target that into food, feed, and nutraceuticals. So our biggest market at the moment is into the feed business, pet food, premium pet food in particular. But we're breaking new ground now, having a nice contract signed recently in infant nutrition in Asia Pacific. And Asia Pacific is our main focus and where we're placing most emphasis in terms of the market because of their, I guess, historic and cultural preferences for fish as a primary source of protein. We produce a 75% protein called ProSure. We have a marine mineral business, what we call White Cal, and an omega-3 powder that we produce, not an oil, a powder we produce. We call that Omega Blue. Next slide, please. So we've incorporated, I think, maybe dairy technology in its basic form. And we've used a new raw material in terms of fish. But in dairy technology, it's all based on liquid. And what we've done is we've introduced solids. So when you break down the fish, you've got a high percentage of moisture in blue whiting. 75–80% of the fish is moisture. But you've also got the solid parts, and that makes processing from a dairy perspective really, really challenging. And that's what we've spent the last number of years doing, is trying to optimize that technology. And we now have it optimized, and we now have the technological risk removed. And in the process over a period of time of testing and evaluating, you can see the bottom right-hand image here is us in Tokyo 2 years ago with our Japanese customers. You tend to optimize the market, and you tend to understand what the market needs. That takes time. And it would be fantastic if we all had a magic wand and say, look, this is what we're going to do today, and tomorrow we're going to be profitable. That's not the way this business works. We're looking at alternative proteins here that we have to introduce to the market, that we have to educate to the market. And despite all of the blue sky projections and thinking that people may have around potential, ultimately people have to make a business decision to purchase your ingredient. And in doing so, you either have to launch a new product with a new ingredient in it, or you have to displace an existing ingredient. And that takes time. Next slide, please. So having I suppose, built Monaghan, our first facility, and being operating in there now for the last 3 or 4 years, we're now moving to the next phase of our development, which is a large-scale facility, 3 times this current size in Killybegs, which is our home port, home of the Killybegs pelagic fishermen who own the company. And we hope to start work on this new facility early to mid 2022. And on the basis that, as I've said, we've de-risked the technology, we understand it. We know what we would do differently second time around in terms of positioning of machines, flow of raw material, etc., etc. And those learnings we can then bring to scale. And offering scale to the market is also important because, being able to produce something in kilos is nice, and it's very valuable. But kilos are of no value to the majority of ingredient companies. They need to be able to guarantee their production line ongoing material supply from you. So you have to be able to scale with customers. If you can't scale with the customers in terms of the opportunity, they will leave you behind. Next slide, please. So the market opportunity, next slide again, just very high level stuff. The trends are fantastic. We all know that. Anybody who's involved in seafood and the blue economy will know that, health and well-being is a huge focus. People are concentrating more in terms of COVID. What are they eating? How are they creating a better health for themselves? That focus on health, the growing world population, etc., that we all know about, create a great platform, but just a platform for the market opportunity around protein particularly, and opportunities from the blue economy. Next slide, please. And in terms of that growing opportunity in the market, you know, traditional protein sources are coming under pressure. They're coming under pressure from a volume point of view, but also from a sustainability point of view. And we can see in the market, and it's not just the media clippings, you can see when you talk to customers, they're looking for alternative proteins. Up to now, alternative proteins has tended to mean vegetable proteins, plant-based proteins, and that's fine. And there's a place for them, no question whatsoever. And I'm not saying otherwise. But naturally, I would say that we have a fantastic opportunity with our amino acid profile, with our high level of natural protein in our powders, to position ourselves as that space between traditional dairy and plant-based proteins. Okay, so that's where we're tending to position ourselves. And it's a really interesting and sweet spot that not everyone gets, but a sufficient number of people get it to make this a very interesting opportunity moving forward. Next slide, please. So in terms of our USP, next slide. Our USP is fish. You know, we've got access to raw material. We're basically on the edge of the Atlantic Ocean, over 1 million tons caught in Irish territorial waters every year. Not a lot of it comes into Ireland. How can we add more value to this? If we can add more value to it, then fantastic. We've got not the traditional breadcrumbs, but a new protein and mineral product. And we think we've got fantastic opportunities also in terms of offcuts from processors and current underutilized products where we can add considerable more value. Next slide. So in positioning in the market, we position it against whey, so whey protein concentrate, whey protein isolate, and whey protein hydrolysis. And what we're trying to do is attract the market by saying it is similar to this in terms of educating the market, but here's the discount we will offer in terms of pricing. I'm conscious of time now, so I need to go to the next slide again, please. And central to that, in partnership with that, is the role that science can play. Science can't come ahead of the commercial opportunity. They must go in parallel. In fact, I would say the commercial opportunity and understanding what the market wants should dictate, absolutely dictate, what the science does. And if the science then supports the commercial opportunity, you've got a winning proposition. If the science identifies products and opportunities that the market doesn't want, then from my point of view, what's the point? Okay, that's it. I think is my last slide. Thank you very much. Hopefully 10 minutes.
Yeah, you're pretty bang on, Jason. Thank you for that. And our final speaker in this session is Heather Burke. Heather.
Hi, everyone. Thanks for the introduction and the opportunity to speak to you today. As Marguerite mentioned earlier, I'm a director of an applied research center here at the Marine Institute in Newfoundland. At the center, we have 15 researchers, 2 postdocs, and 4 grad students working here. We also have 2 pilot plant facilities, a land-based recirculating aquaculture facility, and a number of associated research labs. Today, I'm going to talk a little bit more about my own research interests and some of the work I've been doing on a PhD thesis, a bit of a late starter to the PhD process, but almost near the end now. I'll be finishing my thesis work in the spring. My thesis work focuses on the extraction of multiple bioproducts from snow crab processing byproducts using breeding technologies. So that's going to be the focus of my presentation today. I should also say that I've been recently working on a number of projects with a number of partners in Canada, the US, Europe, Argentina, and Australia on crustacean bioextraction and bioconversion projects for nutraceutical, biomedical, and bioscience applications. So hopefully some of this information will be of interest to the participants. So first, a little bit about the snow crab industry here in Newfoundland and Labrador. It's about 30,000 metric tons in terms of volume that are landed annually here in the province. It is the province's most valuable seafood export. In 2020, the total value of snow crab for the Newfoundland economy was about approximately $648 million. So certainly supports the rural economy here in the province. Snow crab is primarily processed as individually quick frozen cooked sections. Now, this generates about 25 to 30% waste. That's comprised of the carapace, viscera, hepatopancreas, hemolymph, residual meat, and gill content. This material is currently not being used commercially, but could potentially be recovered from processing plant butchering stations, and the byproduct could be converted into some of the other products that the other speakers have already talked about. I've categorized them as intermediate bioproducts, which would be things such as chitin, crab meal, proteins, lipids, and ash. These products could then be further transformed into higher value bioproducts such as chitosans, peptides, omega-3, astaxanthin, and marine calcium. Unfortunately, the majority of these crab byproducts are currently still going into landfills or being dumped at sea under permit. However, environmental restrictions are becoming more stringent, making it more difficult and costly to continue this type of waste disposal. So the overall goal of the research I've been working on is to keep this material out of the environment by using simple processes and green technologies so that we can develop new applications for these crab byproducts here in the province. The remainder of my presentation is broken down into two parts. It's based on two studies that I've been working on over the last few years. The first study is called Moving Towards Better Utilization of Snow Crab Processing Discards in Newfoundland and Labrador. And then part two, I'll be discussing the snow crab bioproducts value chain and green chemistry alternatives. Okay. So while it's recognized that full utilization of our crab landings is desirable from an environmental perspective, and that it's possible to redirect these processing discards toward the production of higher value bioproducts, the Newfoundland and Labrador industry does face some challenges, which has limited its use of crab processing byproducts in the past. One of the key challenges is related to the short harvesting season and the rapid spoilage rate of the discards, which makes it difficult to utilize the material in a timely manner. Therefore, we need simple collection and stabilization methods, preferably using green technologies. They'll be key to better utilization of this raw material. So the first step in this study was to stabilize and characterize our crab processing discards. Crab processing byproducts were collected at 3 different intervals during the 2018 snow crab fishing season. I used 2 different pre-treatment methods for a collection, an untreated control sample and a sample that was treated with seawater. The pre-treated samples were first evaluated for sensory quality and elemental composition. They were then further subdivided into 2 different groups for different evaluation of different drying methods as stabilization options. Air drying, which is a typical, very common type of drying methodology that's been in use in the province, and then a freeze drying method as well. The dried samples were then characterized based on their compositional analysis, and that's identified in Figure 1. The 3 variables that were evaluated during this study included seasonality, pre-treatment methods, and the drying method. And each variable had different effects on crab byproduct quality as illustrated in Table 1 in the center of the screen. Seasonality had the biggest impact on crab byproduct quality, followed by the pre-treatment method and the drying method. So for example, I collected samples in May, June, and July. The July samples were higher in lipids. They were higher also in heavy metals, lower in chitin, and they had different amino acid profiles in comparison to the May and July samples. The collection pre-treatment methods also affected quality and handling requirements of the crab processing byproducts, and that's shown in Figures 6 and 7. For example, treatment with the seawater, while it was effective in preventing this blue-black discoloration, which is known as melanosis that we observed in the control samples and quite common with this byproduct material, the seawater treated samples were much more difficult to process because they became softer and more pliable, and it was difficult to run that through our grinding equipment. The drying method had a major effect on the fatty acid composition and astaxanthin content, with higher polyunsaturated fatty acids and omega-3 contents, as well as higher astaxanthin contents obtained through the freeze drying method. So what this study illustrates is that understanding the effect of the various variables and how to control them is going to be critical to implementing effective collection and stabilization methods for crab processing discards in the province. Figures 8 and 9 do highlight that crab processing byproducts can potentially be used for some of the higher value bioproducts previously discussed, whether it goes into a crab meal, it could be used as an ash replacement. In cement products, the proteins and lipids are valuable. The chitin, amino acids, omega-3 and astaxanthin, they're all potentially valuable products. But one of the key factors to utilizing those, we need to stabilize the byproduct material as soon as possible to maintain its quality and treat it as a valuable product and not treat it as a discard. Next slide, please. So we've been discussing the different types of crab bioproducts that are potential, that have been identified as having potential applications as feed ingredients, natural health products. They could be biomedical and pharmaceutical products. They could be used in cosmetics as well. However, what I found during some of my research is that there are very few studies done on these bioproducts regarding the purity and their safety. So there's limited information about some of these bioproducts as ingredients. So in addition to the environmental concerns of using harsh chemicals, which are often used for some of these extraction methods, there's an added health and safety concern for the intended end use of the bioproducts due to possible contaminants from the chemical treatments that have traditionally been used for such extractions. So the goal of the current study is to replace these chemically intensive extraction methodologies with green technologies. So in May of this year, I visited a local crab processing plant to collect fresh crab processing material. And I used a combination of mechanical, enzymatic, and green chemical treatments to extract carotenoids, proteins, and chitin. The first step involved grinding the crab byproducts to a smaller particle size, followed by extraction of the pigments in vegetable oil or fish oil. And this replaced the use of the harsh flammable solvents, which are typically used, which include things such as ethanol, acetone, and hexane. So the products recovered were pigmented oils, which you'll see at the lower left-hand corner of your screen. The remaining solids contain both protein and shell material and was treated with either acetic acid, which is household vinegar, or citric acid, so the type of acid found in citrus fruits. And that replaced hydrochloric acid, which is a strong inorganic acid typically used for this type of an extraction. The products recovered at this step included calcium acetate or calcium citrate solution, not calcium chloride, which you see on your screen, that is a typo, and a protein pigment complex as a solid material. The pigmented oil was collected by filtration, while the protein was separated from the remaining shell material by particle size separation. At this stage, the shell material still contains residual protein, which was removed by an enzymatic process using protease enzymes. This replaced the need for treatment with sodium hydroxide, which is a strong basic solution, which is typically used at this step in the process. So after the enzyme deactivation, the shells and the liquid were separated. The liquid represents a protein hydrolysate product, which can be further dried either through spray drying or freeze drying. And that product is very high in protein. I think my samples had between 60 and 70% protein. The shells can then either be dewatered and dried to produce chitin, and the chitin can either be depigmented or can be left as is. Depends on what you're using it for and what your potential market would require. You can see in the lower right-hand side of the screen, the non-depigmented chitin still has quite a lot of pigment in it. So that indicates to me that I either need to improve or optimize the extraction process, or need to decolorize it further. Unfortunately, to decolorize it, you're still looking at harsh chemical solvents, which we talked about earlier. I have been working with hydrogen peroxide as an alternative, but that has some challenges as well. So the study demonstrated that it is possible to replace chemically intensive extraction methodologies with green technologies for the extraction of these valuable bioproducts, at least on a laboratory scale. The methods do require optimization and scale up before they can be commercialized. And of course, access to markets is a key consideration. Next slide, please. So this concludes my presentation. In closing, I'd like to thank the organizers for inviting me to participate today. I'd also like to thank my marine bioprocessing research team, who you see on your screen at the moment, for their continued efforts to advance the utilization of valuable marine bioproducts in the province of Newfoundland and Labrador. Thank you.
Thanks very much, Heather, and thank you to all the other speakers this afternoon. We've got a couple of questions in the chat. Two of them have already been answered, and depending on time, we might go back to those and ask the speakers to mention them again. But first off, we have a question for Jason. This is from Cleena Griffin from the Marine Innovation and Development Centre. Jason, what advice would you give to other biotech companies to generate leads in this sector? Where did you start? And then a follow-up, were there particular agencies or businesses that facilitated you to connect with your clients? That's a lot.
I'm smiling because I could probably tell you all the places not to go and all the things not to do. So
they're important too.
Yeah. So I suppose, look, it's not straightforward. I think we took a view, right or wrong, that we would get product to market. We would get product to trade shows. We would get samples, and we would evaluate the feedback based on those. There's a guy, I think he's the founder of LinkedIn, actually. Reid Hoffman is an American guy. I've heard him talk before, and he said you should always be embarrassed by the first product you get to market, because he talks about speed to market. And I think what we did was we got product to market, and quite frankly, it was embarrassing at times, but you get great feedback. And I think that's the best way in terms of what we're trying to evaluate is you have to understand the general environment, market environment. You have to understand the applications you're going for. But the best way is not, in my view, through agencies or anything else, but it's actually going out and talking to customers, getting the feedback from the customers, understanding what is it they like about it. You know, what is it that they see as being positive? What are they looking for? And then you take it back and you try and replicate that. So ultimately, in marketing terms, identify the customer's needs and satisfy them. And it's very hard to do that unless you have, I feel, that direct contact with the customers. That would be just, I think, my view. But you know, we've done things right and we've done a hell of a lot of things wrong as well.
Okay, thank you. Jan or Lena, do you want to? Lena, I see your hand up. Would you like to come in there?
Yeah, I could give an example of how some of our member clusters work now, because the Asian markets are, I mean, huge possibilities in China, Asia, South Korea, Singapore, but many of our companies are too small to have one person or two person only working with those markets. And also going out to the market, as Jason said, and just open your suitcase and you have only one product, then you say, no, not here. And then you have to go and open that suitcase with only one product. So one idea that we had that, okay, let's fill that suitcase with several different products and talk to agents in those markets. And they can then say, oh, this product, I can talk to this person, and then work together. So don't look at other startups as competitors, but try to go together into the market with the first products.
That's a very good point. Jan, would you like to come in there at all?
Our products they're just too unique, and I think, you know, we're now in the we're seeking out investors, and maybe next year will be good for us, maybe not. So but I would definitely like to say is that at least in our type of business, you know, the view towards failure or mistakes can't be a negative one. It's just a lesson learned, and you always have to have that mindset and keep on going.
Very good. Thank you, Jan and the others. There's a question here for Heather from Peter McLaughlin. You discussed decoloration. Would recoloration be an option?
I'm not sure recoloration would be an option. Typically, users of chitin and people who use that material to produce chitosan want the color removed from the product. So I don't know if it would be if you would want to add it back. Depending on what the application is, however, you may not need to remove all of the color, so decoloration may not be needed. In my process, I'm trying to recover as much as the pigment as I can because there is value in that pigment. The fact that I have some left in that end product means that my decoloration on the front end wasn't as effective as I would like it to be. I'm only getting about 25% recovery of that pigment. So I'd like to get up to 75% if possible. If I can strip out more of that pigment on the front end, that means I don't have to decolorize the chitin material, or at least not as intensely. So that would actually help the process, and it would eliminate the need for some of these chemicals. So I'm not, I don't think that recoloration would be an option, at least not for the products that I've been working on.
Okay. Thank you. Now there is another question, but I don't think we have time for it. I'm sorry, Eamon, but maybe the panelists would take a look at the Q&A, and if they can respond to Eamon's question on potential challenges for community-based organizations to drive startup enterprises in the sector. If any of you have any thoughts on that, we do that. I'm not sure, am I passing back to Niels or Krista for the break?
Remember, you can just announce that we're going to take a very short break.
Okay, we're going to take a very short break. We'll see you back here in about 5 minutes. Take care.
Okay, everyone, and welcome back. This very short break. We are now ready for our second session today, and this is also the last session of this year's Laurentic Forum. The moderator for this session, with a very creative name, The Whale in the Room, is about the climate change. The moderator is Johan Vidar Ivarsson, and he is the project manager and analyst at the Icelandic Tourist Board, which is a government supervisory institution for tourism under the Ministry of Industry and Innovation. Johan's main area is on projects and research that focus on the economic development of tourism in Iceland, and also its interplay with other industries and factors such as sustainability and environment. Johan has ample experience as an analyst and manager in the financial markets, and also as a university lecturer in Iceland. So please, Johan, the screen is yours.
Thank you, except I'm not Johan, and I'm not from the tourist board.
Okay.
So you were stuck in day one, but anyway, I can introduce myself. So welcome to this final session of the Laurentic Forum 2021, which is titled "The Whale in the Room: Climate Change." My name is Jonas Viðarsson, and I will be moderating this session. I'm the director of division at Matís in Iceland. And one of the many topics we deal with here are fisheries and climate change, which includes analysis of the impact of climate change on fisheries, as well as mitigation and adaptation. Now, climate change is our greatest challenge in the coming years. We're now all looking towards Glasgow, hoping that COP26 will develop real solutions in our fight against climate change. The blue economy is already heavily affected by climate change, and the regions in the far north are particularly vulnerable as we keep seeing stocks migrate, increasing extreme weather events occurring, unexpected algae blooms, invasive species, infectious diseases, and parasites emerging in our waters. Now, we, however, do not fully understand what effects climate change has on our stocks and the ecosystem, how we can mitigate and stop or reverse the development or adapt to these changes. These are the issues that will be discussed at the next 4 presentations here at the Laurentic Forum. Now, the first presenter is Dr. Glenn Nolan. He is the head of Oceanographic and Climate Services at Marine Institute in Galway. Glenn was previously the director of European component of the Global Ocean Observing System in Brussels. He has broad experience in national and European funded programs and in developing Ireland's ocean observing and forecasting capabilities and funding for marine research and development for over 25 years. Now, Glenn, the floor is yours.
Thank you very much, Jonas, and good morning and good afternoon to all the people on the call today. I'm just going to give a very quick 10-minute overview of all of the things that are happening with climate change in Irish waters in 10 minutes. It's a tricky feat, but I'll do my very, very best. So if you could move on to the next slide, I'll just set the context for the talk. And this is an animated slide, so if you just bring in a few of the elements of the slide, that would be great. So there's quite a lot of international drivers and national drivers for climate policy. You have the IPCC reports that you're all familiar with, the work of the Marine Climate Change Impact Partnership in the UK, Food and Agriculture Organization of the UN. We have a strategy within Ireland, a marine roadmap, if you like, called Harnessing Our Ocean Wealth. We have a climate action plan, the first of which was produced in 2019. And very opportunistically today, our 2021 plan will actually be published by our government in the next few minutes, I understand. So we've been working very, very heavily on that in the last few months to make sure that the marine area is very well represented in the overall climate plan. So if you could just bring on to the next slide, please. You might need to click 3 times or so. So This is a schematic of the North Atlantic, and I hope it conveys the fact that we in all these different regions who are part of the Laurentic Forum, we're all connected. And I'm an oceanographer, and I believe we're connected in lots of ways, and particularly by ocean currents. These are the major circulation pathways in the North Atlantic. And you'll see that water, the blue cold water, forms in the Labrador Sea off Newfoundland and makes its way over the course of maybe 8 or 9 years and ends up off the west coast of Ireland in the Rockall Trough. And then it recirculates via Iceland and Greenland and back to the Labrador Sea. And a major arm of the Gulf Stream actually goes from the US and Newfoundland and comes across the Atlantic, passes Ireland, and then heads onwards to Norway. So we're all connected by ocean currents. And I think it's important to emphasize that. So that's one of the first things that connects us all. But understanding the changes in this system, that's a very important task that we're all charged with. And it's great that we have a framework for cooperation and collaboration like the Laurentic Forum, and also through things like the International Council for the Exploration of the Seas, which has membership from all of the countries represented in the Laurentic Forum. And we share oceanographic information through that forum every year. Next slide, please. So this is a slide prepared by Dr. Igor Yashayev, who works in the Bedford Institute over in Halifax, or in Dartmouth, I should say. And again, it's just another way to say the same thing. You can see how the currents over a 20-year period, these are the average ocean currents, surface currents over a 20-year period. You can see how all of our regions are interconnected with these red arrows and blue arrows and so on. Next slide, please. We try to observe what is happening and changing in the ocean around Ireland each year. We've been out there since about 2004 or so. These yellow dots that you see on the map are what we call our standard stations, where we stop to collect oceanographic information either on the chemistry of the water, the physical properties of the water, or some biological elements as well in terms of plankton, both zooplankton and phytoplankton. Next slide, please. So we've observed the temperature in Irish coastal waters since about the 1960s. We've done that in conjunction with the National Met Service, Met Éireann. And what you can see in this graph is the temperature starting from around 1960 up until the present day. We've observed nearly a degree of warming at this station. Malin Head is pretty close to the northernmost part of the Republic of Ireland. And we've seen this warming, as I say, of about 0.9 of a degree over the last 60 years, which you can see quite a few wiggles on the graph as well. So it's not a straightforward linear trend. There's natural variability that modifies and modulates this signal. So we need to record this information at very high resolution temporally to understand what's going on in terms of ocean temperatures. Next slide, please. So we're also concerned about sea level rise. I think everybody is. And under an extreme emission scenario over the coming century, we may see sea level rise of up to 1 meter according to the projections that are available now. And if you can just advance the slide once more, I want to show a regional picture of Ireland where you can see, I hope from this color coding, that the degree of sea level rise will differ depending on where you are around the coast of Ireland. So in the south and southwest in particular, you can see that the amount of sea level rise in meters is much more than it would be in the northeast of Ireland or the north of Ireland. So we have to factor in these subtle differences between different parts of our island to when we're thinking about planning for future sea level rise and changes we may need to make to coastal infrastructure to cope with this rise. Next slide, please. We're also concerned about the health of marine ecosystems and in particular water column chemistry. We are worried about ocean warming and acidification, the loss of oxygen, of what they might call oxygen minimum zones, and changes in nutrients that are critical to some of the processes that were described by Jason and some of the other speakers in the previous session. So we're particularly interested in the multiple stressors that occur. So you may have ocean acidification occurring alongside changes in temperature and changes in oxygen that ultimately affect the species that live within the ocean. So one of the things we need to do is report on this through the UN process, the Sustainable Development Goals. There was a dedicated Sustainable Development Goal on ocean acidification, and we collect the data to report in under that metric of change in the ocean. Next slide, please. We're also interested in what happens with our fish stocks. Not just interested, I mean, it's a very, very big sector in Ireland. And Jason in his talk mentions the prospects of harvesting blue whiting, which is represented in the middle panel of this plot here. So what we've done here is our colleague Louise Vaughan, who works in GMIT, in local higher education institute in Galway, she's looked at different fish stocks. And what you see on these plots are two things. You see what they call the biomass of the stock, which is depicted by the red line. And you can see in the upper panel cold water stocks, which have been declining in our waters as our oceans warm. You can see herring and Celtic sea cod in particular. In the middle panel, two panels, you can see migratory species like Atlantic mackerel and the blue whiting. And the picture is a bit more complex with them. And I don't think we can draw any conclusions necessarily about their changes in their distribution just yet. And in the bottom panel, you can see the warm water species are increasing in our waters. Superimposed on these maps is the fishing pressure. And one of the very complicated things is to actually separate out all of the different stressors that will reduce to a change in the distribution and abundance of different fish. You have to think about the fishing pressure. This is the fishing effort effectively. And then you have to think about all the climate stressors as well to try to build a coherent picture of the relative contribution of each of these things to our changing fish stocks. So if you can just advance the slide by one. So you might have a very simplistic view of climate change in a fisheries context that, you know, beforehand we were eating the following species, and in the future we're going to be eating all these new exotic species that are, you know, or that maybe we didn't catch before, and it's a very exciting prospect, and it may well be an exciting prospect, but I think we need to understand some of these changes in detail to allow markets to evolve and to allow people to make the changes. Even fishing vessels were having to change how they fish, when they fish, the type of gear that they use, and so on. So I think this simplistic view of the before and after is probably too simplistic, and we need to delve in a lot more detail into fish stock changes over time, and we're in the process of doing that. Next slide, please. So in the last couple of slides, I just wanted to show what a framework for climate services might look like. This has been developed by the Marine Institute, but it is very much factoring in all of the requirements at national level. So you have a requirement gathering exercise. So I'll talk about who might be involved in that in a moment. But I think in order to meet those requirements, we need to observe the different key processes in the ocean. We need to try and understand the things that we don't currently understand, you know, food web dynamics, the precise mechanics of ocean acidification and different things like that. And we obviously need to understand how our climate is going to change in the future. That's the projections on the right-hand side. We need to work with people to co-develop services. I think the thing that's very clear to us is that a Marine Institute on its own will not be delivering all the marine climate services for our country. We have to work with our weather forecasters and climatologists. We have to work with our public works ministry. We have to work with our environmental protection agency and many other stakeholders to develop the services for end users. And we need to make sure that there's a feedback loop between those services, and we can redefine the requirements and then maybe change what we observe and change some of the research and development that we do over time. So if you could just bring in maybe with 4 clicks the remaining elements of this slide. So the first part is about industry involvement in this matrix, if you like, this framework. Industry have their own requirements. If you're involved in a maritime industry or marine industry, you will want to know how climate is going to affect your industry. So you are entitled and able to express your requirements. I need to know more about a changing fish stock, the changing shape of the coastline, whatever that is. Industry are also involved in gathering observations. You know, they make observations as part of the day-to-day work. We've worked with aquaculture producers in the past to actually gather the basic scientific data. And industry will also be beneficiaries of some of the services that are produced. Academia will help us with our understanding and also with some of the projections for climate. Communities through local authorities and municipalities will help us define what the requirements look like. And they'll help us to develop some of the services in a fit for purpose way for them. And finally, the government sector will work on the requirement definition with all of these other partners. They fund and make a lot of the observations. They will be involved in the co-development process, and they'll be involved directly in the provision of services to end users. So this is what Don referred to a few days ago when we were preparing for the conference as the quadruple helix involving all these players. So there's a role for all these players in a framework for climate services. Next slide, please. So one of the challenges we've had is working with local authorities in the climate context. What we find is in the climate offices and local authorities, they tend not to have specialist climate expertise within those offices, but they are still the people who are charged with communicating climate change to members of the public and broader stakeholders. One of the things we've done is we've worked with some of the climate regional offices to develop these infographics that explain things like, in this case, harmful algal blooms, so that a member of the public can understand why a harmful algal bloom is important and steps you might take to mitigate the effects of harmful algal blooms and how they might change over time. So I hope that's given you a very quick insight into some of the work and some of the concerns that we have. And thank you very much for your attention.
Thank you, Glenn. Then we move on to our next speaker, which is Dr. Darrell Mulroney, who is a shellfish research scientist at the Fisheries and Oceans Canada in St. John's and a lecturer at the Marine Institute of the Memorial University of Newfoundland. Darrell's research focuses heavily on population dynamics and productivity drivers of snow crab, both within Newfoundland and Labrador and globally, and how best apply biological processes into resource management strategies. Darrell's work is recognized and applied both domestically and internationally. Now, Darrell, the floor is yours.
Oh, okay, thank you. Can you hear me okay?
Yeah, loud and clear.
Okay, thank you, and wonderful presentation before mine. Yeah, I'm Darrell Mulroney. I'm a research scientist with Fisheries and Oceans here in St. John's. I'm going to talk about snow crab. I think Heather Burke mentioned earlier how important it is to us. I think she said close on $650 million fishery this past year. So this is really an important fishery to us. So I'm going to talk a little bit about things that affect snow crab in the past, the present, and the future, kind of a little bit of a chronology on what we think we've learned over a few decades of research on snow crab. I'll just draw attention to the three images on the left-hand side of the slide there. I think we're probably pretty familiar with the carbon dioxide story on the very bottom one with the emissions coming out of the stacks. And we're probably fairly familiar with fishing in the pots that we can see there in the middle one. But the top one, this one, the Arctic oscillation, I'm going to focus on this a little bit. And this is it's a climate index, kind of a multivariate climate index. That's a signature, if you will. So this is about the exchange in time and space of high versus low pressure systems in the Arctic region. So it's got cousins called the North Atlantic oscillation, which we may be a little more familiar with, or things like El Nino that we hear a lot about. So we'll focus on the one that kind of lives in the Arctic. Go ahead with the slide, please. So a lot of stories about Newfoundland and Labrador fisheries, of course, start in the early 1990s when there was an ecological regime shift on our marine shelf, coupled with overfishing of some of our fin fish stocks, which rendered the ecosystem profoundly changed thereafter. So on our little newspaper clip here, we can see 19,000 people out of work during this time. It's a bit of an underestimate. Revised estimates are in the order of 30 to 40,000 people in the industry out of work. Kind of the largest mass layoff in Canadian history is a bit of the jargon that's used. There's a bit of a story or a thought out here in our society that, well, here came the crab because the cod kind of went away. And it's partly true, but partly not true as well. So we can see in the top right graph here, these are the landings of snow crab from Newfoundland and Labrador. And that big spike in the middle, that's 1999, where we took 70,000 tons. That was our biggest fishery. But the point I want to make is we built it up there from the early 90s into its peak there in the late 90s, and kind of have been riding a level of 30 to 50,000 tons a year thereafter on the lower end of that in recent years. The green part is the Grand Bank, 3LNO, just outside of St. John's Narrows, and it's an underwater shelf system about the size of the island of Newfoundland. So it's quite a large ecosystem, and it's a very cold ecosystem. The Labrador Current delivers much of her water directly to the Grand Bank. So I want to kind of correct a little bit of the story about, well, the release of predation from the cod must have brought on the snow crab, because it's not quite right. if we look in the bottom panel, this is the closest to history that we have on measuring stock size for snow crab in Newfoundland and Labrador. And so that black line is the catch rate index on the Grand Bank in the fishery. And that gray line is a bottom temperature index from just outside of St. John's Harbor in something called Station 27. And I've got it shoved ahead 9 years here in this case. And we can see when we look at the lag set, we've had cold periods in the 70s, we've had cold periods in the 80s, and we've had cold periods in the 90s that have brought on subsequent big fisheries of snow crab. So the inference being that cold conditions during early life seem to be a very important controlling mechanism for the snow crab. And we have had a long regulation through climate control on snow crab, not just after the collapse of the marine ecosystem in the 90s. Next slide. So on the previous slide, the lesson was we've had bottom-up control of the stock for a long time. So as we kind of began to learn more on this thing, we've started to realize too that we can have fishing control. So control of most commercially exploited species operates in two directions, the bottom up and the top down. And so this slide here is about the top down effects that can occur on snow crab through fishing. So we had some elevated exploitation rates. I'm going to draw our eyes to the black lines in the middle graph. And those are divisions. The leftmost one is off of Labrador, and then the center one is off of the northeast coast of Newfoundland. And then the right black line on the 45-degree angle kind of thing is the Grand Bank here. So we can see generally increasing exploitation rates throughout the time series as we've been fishing this. So we put progressively more and more fishing pressure onto snow crab over time, and in Labrador in particular in recent years, up to 60% harvest rate on the exploitable portion of the crab in many recent years. So we've been putting pressure on it. And one of the things that happens when marine organisms are stressed is a change in the size at which key life events happen, and something like changes in size at maturity happens. And so we know this happened in cod with the fishing pressure, and it happened in capelin, which have been smaller size at maturity since the event in the 90s as well. So to cut to the chase, in the top panel, we can see males and females, the males in the dark lines and the females in the gray lines. And we had a shift in size at maturity in our northern areas off of Labrador and the northeast coast, and a little bit on the Grand Bank, not so much. So in these seahorse plots to the right, these are the sizes at which crab have been terminally molting. And in snow crab, terminally molting is the same as maturing. The animal is done growth and is now an adult, a mature adult. And we can see this shift kind of from the darker lines happening at larger sizes at terminal in the early years, and the yellow lines kind of shifting up and left. And this is indicative of the crab over time starting to mature at smaller and smaller sizes. So what we learned here, to go to the bottom panels, these are three options that a crab has in any given year of when it undertakes its molt. It can do a regular molt and stay as what's called an adolescent crab and come back to molt again. It can take a year off and skip molt, which we see in the middle panel there on the bottom, or it can terminally molt into an adult and give up growth. So the regular molt has this dome-shaped probability of occurrence of undertaking a regular molt happening. And what's interesting is on either end of this dome shape for a regular molt probability are the skip molt and the terminal molt. And so if we look at our x-axis index here, which is the density of crabs in the population, we can see under low density that the animals are going to terminally molt more. So this is indicative of competition release, intraspecific competition release, allowing the animal to move on from the need to compete and just simply go to reproduction. So this is kind of a classic biological story that occurs when resources are over-harvested. So the lesson here on this slide is, now we've learned that we can have fishing effects on the crab as well. So we have bottom up to start, and now we have fishing effects we've learned. So next slide, please. So this is just a little bit of an update on some stuff that I'm doing at present. I'm exploring productivity of snow crab in Newfoundland and globally, all major stocks, with a linkage with sea ice and the Arctic Oscillation. So this is a model that I've developed here to explain the biomass, the fishable biomass of snow crab, based on a intrinsic natural cycle that happens in population growth, along with the extent of sea ice 11 years ago, and the Arctic Oscillation during pelagic stages of the snow crab life history, so the spring and summer months 11 years ago. So this is about productivity and regulation at birth through the climate regulator. And lo and behold, it explains it very well. Not only does it explain it well in the Newfoundland and Labrador stock, it explains it well in all global stocks. So this is pretty hopeful line of research that we're on here. But an observation I want to make is in 2019, we can see what's called a residual, and we're coming in under projected biomass in 2019 and 2020. So the lesson here is that it's still under climate regulation, but that we're underwhelming in terms of where we might be due to a little bit of top-down fishing effects. Next slide, please. So where this research is heading, and I'll quickly draw us to the right-hand graph, is to model how CO2 and the Arctic Oscillation are going to play out moving forward in regulating ice habitat for the snow crab. And so I just want to go to 3 o'clock on the graph in the red and blue stripes. These are coming along the bottom as carbon dioxide. And so in the Arctic Ocean region, we can see the left axis, the Arctic Oscillation is what controls the ice level. Whereas if we look down one in East Greenland, and we can see this vertical blue and red stripe pattern, well, that is as carbon dioxide increases that the ice shrinks. So carbon dioxide has control there. And overall, in all regions, carbon dioxide has control for the most part. So what we see here in the bottom right panel is just projections of the potential habitat for snow crab in the Newfoundland region moving forward, Baffin Bay and Newfoundland under best and worst case CO2 scenarios. And basically it's projected to shrink. And we're doing this for all major regions. And I assume the time is up, so we can flick the slide. That was the last one anyway. Just want to make the point on the top that snow crab habitat is actually opening up in new frontiers, potential new frontiers on the planet, whereas it's shrinking in its historic ranges there in the middle panel on the right. And overall, it's in a growth phase, but we're not projecting that the growth phase of snow crab habitat on the planet is going to continue to open up for long. Thank you.
Thank you, Darrell. Very interesting. Then the next speaker is Ragnhildur Friðriksdóttir. She's a project manager here at Matís. Her background and education is within biology, marine environmental science, and resource management, and more recently within climate change and its impact on fishing and agriculture sectors. Ragnhildur, the floor is yours.
Thank you. Can you hear me? Okay, yes. Great. So yeah, thank you, Jonas. Happy to be here. So yeah, my name is Ragnhildur, or just Raga, and I will be today talking to you about well, the potential impact of climate change on the fishing industry and coastal communities. There will be winners and there will be losers, and I'm gonna attempt to give kind of a general overview of what might happen, how it might affect the fishing industry, and try to reflect that to the coastal communities, since that is our main topic here, and how and why we need to prepare and adapt. So I'm gonna kind of, instead of focusing on any specific results, I'm gonna try to give more in a general overview. I will also be talking a bit about the ClimeFish project, which is a EU project that ended a year ago, or last year. It was a project coordinated by the University in Tromsø, funded by the EU Horizon 2020 Research and Innovation Program. And in this project, we were looking at the impacts of climate change on fisheries and agriculture. We had, I think, yeah, it was 16 case studies that we were looking at. We were doing biological projections, we were doing risk assessments, and then creating climate adaptation plans. And from that, we developed a specific methodology to create these kind of climate adaptation plans that I want to also be discussing briefly. Next slide, please. So just to start, you can click maybe twice, I think, to get all the text out there. So just to, again, to give this broad overview of what might happen, what we might see. So this is just a few examples of the impact that climate change might have on the marine environment and marine life. And here I'm not taking a regional approach. This is kind of the overall approach. Some of these impacts have already been mentioned by Glenn and Daryl, sorry. So what I want to mention here as examples are, of course, increased temperature and ocean acidification. These things might be of special concern here in the Northern Hemisphere. And then we have changes in ocean currents and circulation, as has already been mentioned. We might see shifts in fish distribution and migration behavior, which has also been mentioned already, as well as changes in stock sizes. Changes in growth rates and age of maturity. And if you click once more, I think there's something there at the bottom. Yeah. And then changes in marine food webs and food availability. Yeah, next slide, please. So if we just look at how these changes might potentially impact the fishing industry. So the models do suggest a decrease in the maximum catch potential, but this is like with a global overview. So some areas are expected to see an increase, while others will see a decrease. So it's generally considered that at the higher latitude, we are more likely to see an increase, while closer to the equator, we will have more decrease. And the most pessimistic model suggests somewhere around 12% decrease globally. Increased complexity in negotiating catch quotas. This is something that is likely to happen when fish stocks move, especially between EEZs. So this is something that really needs to be considered. More challenging conditions at sea might mean a lot of things, actually. It might mean increased risk for the fishers, as they need to maybe go further. And obviously, if we have more extreme weather events, we will have more risks of injuries, damages to infrastructures, and with worse weather and worse fishing conditions, we might also see fewer days at sea. We might see depletion and migration of local stocks, which again might mean longer distances to the fishing grounds and additional risks related to that. And of course, an increased economic burden. It will be an economic burden for the fleets if they need to travel further ashore. And also they might need more time fishing. Other examples are changes in the catch composition. And then we will, as has been mentioned as well, that species will come and species will go. We will have, just like here in Iceland, there have been I think it was over 30 new species here in the past 10 years or so, I can't really remember, that have been coming here to the EEZ. Next slide, please. So back to the Climefish project, I just wanted to show this slide. So regarding the case studies that we have had in the Climefish project, we had 6 case studies that were focused on marine fisheries. And here it's just a general overview of common impacts that was shared between these case studies. And just to give you an idea of some of the results that we had in that respect. We have, for example, for the species composition, we have the northward shift in species, increased stocks, decreased stocks, emerging species. We have changes in species phenology and growth. I'm not going to go maybe through all these. I don't really have the time for that. Changes in distribution and fisheries dynamics, and changes in quota allocations and licenses. For example, in the Northeast Atlantic case study that we did have, one of the highest ranking risks that we had were related to the increased complexity in negotiations as a result of changed distribution of species. And then production dynamics as well. As I mentioned, longer distance to fishing grounds, reduced safety, damages to infrastructure, and so on. Next slide, please. So what could this then mean for our coastal communities? I mean, all the changes that I've mentioned can affect all kinds of fishing activities, from the small scale fishery to industrial fishing. Again, what needs to be mentioned here, that these are what might happen are not only reflected in the challenges and the risks. We will also have some opportunities, and that is something that we also emphasized in the Climefish project. So we also identified key opportunities, because we also need to be prepared to grab those opportunities if and when they come. So, I mean, if we look at the risk, fishers and fishing community might no longer be able to access the species that they are accustomed to fishing, which obviously could impact their livelihoods, food security, local culture, and alongside other economic and social consequences along the entire seafood supply chain. So we cannot always be focusing just on the environmental and biological changes. There are and can be severe economic consequences and social consequences. And climate change could then reduce the resilience of the fishers communities. And of course, if we don't have the fish, that could have severe negative impacts for regional developments. If people lose jobs, lose their livelihoods, that will have negative impacts for the regional development. Or in some cases, it might also have positive impacts if we have new opportunities, new species arriving, and so on. So that also needs to be taken into account. So communities then that are dependent on fisheries must be resilient, and they need to adapt to remain viable in the face of climate change. Next slide, please. So then what is climate adaptation? Just so that we're all on the same page. So climate adaptation is the process of adjustment to actual or expected effects of climate change. So here we're not talking about the mitigation, climate mitigation, where we're trying to reduce CO2 emissions to try to prevent climate change from happening. Here we're talking about adjustments of the effects of climate change. So this includes changes in processes, practices, and structures to reduce or avoid potential damages or benefits from opportunities. Next slide, please. Usually, just to give you an idea, adaptation measures adaptation is divided into these two incremental adaptations, which are smaller adjustments to maintain the essence of an existing fishery aquaculture system. And these are smaller actions, such as changing gear or fishing methods, strengthening infrastructure, updating health and safety policies, even, or procedures. And then we have bigger changes that are transformational adaptation. And here we're talking about fundamental changes at greater scale. For example, legislative changes, changes in livelihoods, and so on. So there's really no one size fits all here. Yeah, so I think I'll just go to the next slide. So in the Climefish project, what we did, we created these climate adaptation plans for 7 different case studies. And from that, we used the lessons learned and a lot of stakeholder dialogue to create climate adaptation plans for these fisheries and aquaculture industries. And so we created this method that has been published in the Climatic Change journal. And as well, we created this standard workshop agreement. If you can click once, I want to go briefly through what our process was here. So this process is very stakeholder based. We had regular stakeholder meetings throughout. So the first step was to evaluate the current status of the fishery or the aquaculture in question to really understand what is going on and serve as a baseline information. And then we do forecasts when possible, modeling, but that is not a requirement. And then after that, we do a risk assessment to evaluate both the risks and the opportunities at hand. If you click again. And based on that, now we have the main risks that are then based on both the modeling and then the stakeholder input as well, which has proved extremely important and really showed that it is extremely important to include stakeholders from the beginning of this process. So we did a vulnerability assessment based on the main risks, and identified the adaptation needs. So what do we need to adapt? And then from there, we created a list of adaptation measures. And then the final step in this is just the implementation plan. So we need to understand who is responsible for making the change, what is the cost, and so on. And once more, yeah, thank you. And so the outcomes of this process, which I encourage you to have a look at, this publication, if you're interested, is to a list of main risks and opportunities, risk of main vulnerabilities facing the fishery aquaculture in question, adaptation measures, and an implementation plan for the adaptation measures that have been identified throughout. Yeah, I think I'm out of time. Yeah, once more, I think that's it. Yeah, thank you. So yeah, I just wanted to give you this quick introduction into what's happened in ClimeFish, and yeah, encourage you to have a look at the publication if you want further information. Thank you.
Thank you, Ragnhildur. Just went a little bit over time, but no worries. So now we go to our next and final speaker. It's Steinar Rauns, who is Senior Advisor at the Department of Industry and Economic Development at Troms and Finnmark County Council in the northern Norway. He's a Master of Science in Fisheries from Norwegian College of Fisheries Science and has over 30 years of research and advisory experience in the field of management and planning of natural resources. He has been a researcher at the Norwegian College of Fisheries Science and NOFIMA, and advisor to the Ministry of Trade, Industries and Fisheries, the Regional Council of Northern Norway and Northern Trøndelag, and several counties and regional councils. He has also worked many years in the industry, both in fisheries, agriculture, tourism, and oil and gas. Since 2013, he has worked at Troms and Finnmark County Council as project manager and senior advisor with marine spatial planning and regional development. He has also been and is responsible for several major projects related to coastal development, both at national and international level. So, Steinar, the floor is yours.
Thank you for the presentation. As you understand, I haven't followed the straight path. I have been moving around, but mostly around the coast. And I will, can you change? I will give a short presentation about our project, where the main ambition is to turn climate commitments into action. Next slide. But I will start with a picture. And with this picture, I will just point to two things. First, that the coastal communities are in the front line of climate change. And the other thing is lighthouse demonstrators. Troms and Finnmark County has now become a lighthouse demonstrator in relation to climate resilience. Next picture. This happened through a project called Impetus and was funded by Horizon 2020, and which started this October. The main ambition here is to action to protect the communities and the planet. We want to give better informed decision making and support vulnerable sectors and businesses. Next. As I said, Troms and Finnmark County is a lighthouse demonstrator in this project, one of 7 others. Next. And we are the Arctic and coastal demonstrator. The others you can see here is in other places in Europe. Next. And within this project that will last for the next 4 years, we will work in a close relationship and collaboration with research, government, industry, and communities, and working together to help communities, business, and regions to become more resilient. And one of the main tools we will use in this work is to develop a regional twin of the region. Our regional twin will cover the whole county, both land and sea, and the coast. Next. And our ambition is to provide new insights and data deliverings to target climate response. And through this process, we hope to develop insights and demos that we can share and help others so that it's possible to scale them up. Next. But as all the previous speakers has pointed out, the issues of climate change is huge. It's a big wave, and we have to prepare to be able to ride the storm. And in the Impetus project, we will have a lighthouse demonstrator that will cover land and the coast. But we feel that it is also important to have a stronger focus on the sea and the ocean. One of the reasons for this is that the ocean will be of so importance in order to meet and solve the big waves of climate change, both in respect with be able to capture and store carbon, and in the other case, to provide us with more marine proteins. That will be of extreme importance. And in the Impetus project, we will focus on climate change and its effect on marine spatial planning. But as the previous speakers has shown so well, in order to understand the changes that will occur at our coast, we have to go far beyond the coast to understand the relationship. We have shown what the circulation will be, and we have also shown how the temperature will contribute to have changes in the distribution of fish. And we are moving towards a nature that will go from being quite secure and quite stable towards a nature that is more unsecure and more changing. We have to get a better understanding of these changes, and we have to improve the responsive capacity of the coastal community in order to respond to those changes in a best way. And in order to do that, we think that it is extremely important that we work together, and that we work together across the Atlantic. So next. So that is why we are focusing much on the other mission, the mission Ocean. This is a very important mission, and I think we all together should have a look on this mission, and especially have a look on the lighthouse demonstrator. I think we should think about an Atlantic lighthouse demonstrator, where we across the Atlantic, the coastal community and the researchers and the public in general work together to meet this challenge and to solve it. I think next, if we are able to work together, I think we will be able to ride the storm, and I think we will come to a safe harbor and make sustainable coastal communities. Thank you for the attention.
Thank you, Sten-Arne. So this was our final presentation, and now we can go for a short panel discussion. I haven't seen any questions here, but I can at least start with a few questions. I was wondering, Glenn, I'm not even sure that you will be able to answer this, but you said that we will be catching new species or more exotic species in the future, and we just need to adapt and learn how to eat these new species. As I see it, this is a relatively simple way for a researcher to say what needs to happen, because in the end, it's usually the politicians that make the big decisions. And we now, for example, see that we have hake in the North Sea, and due to relative stability, the North Sea coastal nations don't have any quotas in hake. We have similar things going on in the mackerel fishery in the Northeast Atlantic. I'm not even going to mention Brexit, which also makes things more complicated. But like I said, Glenn, I'm not sure that you can answer this, but I mean, is it maybe just pointless for us as scientists to be identifying solutions when in the end it's just the politicians that will maybe just disregard our advice?
I have to qualify, Jonas, from the outset. I'm not a fishery scientist, but you know, I have a lot of faith in our ability to provide the evidence base to support policy and political decisions that need to be made. And I think we just need to continue to do that, to come up with the best science, put that in front of the people who negotiate the quotas and who are engaged in some of the political processes, and hope that they continue to conserve fish stocks and make sure that the maximum sustainable yields, you know, those types of metrics are adhered to. So I think in my case, I retain the role of the humble scientist providing the evidence base rather than trying to solve those very complex, as you say, political and policy questions. I mean, the policymakers are very interested in things like storminess as well, you know. So how is storminess going to change over the next decades, and what changes do they need to make in policy to account for this? So I think there's areas where scientists can certainly help, and it goes back to the point I made about this co-design, you know, this co-production. I mean, storminess isn't really something I as an oceanographer can do. I can look out the window and tell you that the waves are big, but a meteorologist is going to be required to tell you how intense a storm is and whether that's likely to change over time. So I think that whole co-production side of things is going to be very important as we, as scientists, inform policymakers into the future. So I'm sorry I haven't directly dealt with your question, but that's the best I can offer, I'm afraid.
And I'm sorry for being so negative. Maybe if I go to Ragnhildur now, it's almost the same question, because I know one of the case studies in Climefish were on the pelagic species in the Northeast Atlantic, and maybe you can reflect on this, because as far as I remember, it's not the science and what needs to be done, it's rather the negotiations on the quotas that were a big issue. Isn't that correct?
Yeah, that's true. So in the risk assessment process in the Climefish project, so you're right, one of the case studies was the Northeast Atlantic pelagic fisheries, and the highest ranking risk. So we included the stakeholders, like I said, from the beginning. So to the first stakeholder meetings, we brought the results from our model projections and we discussed those with the stakeholders, who then gave their feedback and additional inputs. And then they were asked to give feedback to express on both the severity and the likelihood of these impacts. And so we created this the results from the risk assessment that derived from that conversation with the stakeholders and the scientists. And the highest ranking risks from this particular case study was exactly this. So this increased complexity regarding the quota negotiations, and then you know, the risk of overexploitation as a result from that. So that was really high on the agenda in the Northeast Atlantic case study.
Thank you. Maybe continuing on this, you said that the involving the stakeholders was so important, but why is that? Isn't it just enough for the government to come with the solutions and present it to the stakeholders? And also maybe a linked question, most of the fishing industry is, in my mind, just thinking about the next 2, 3, 4 years at most. Are they really interested in long-term effects?
So to address your first question, so yeah, we really experienced the importance of including the stakeholders from the beginning. What happened was, like I said, we started off with bringing the pure science, the biological projections at the beginning. And what happened is that after the dialogue with the stakeholders, which was quite intense, in almost all of the case studies, it ended up kind of broadening the scope of what we were dealing with in each case study. And in some of the case studies, the resulting adaptation measures that came out of the process was, in some cases, over 50% of those adaptation measures were kind of derived from impacts that originally came from the stakeholders that were then taken into the modeling process. So, I mean, that really broadened the scope in almost all of the case studies, and it really showed us that, you know, these pure science-led plans, they you know, it really benefits the process to include the stakeholders, because they are the ones that are on the field. They are the ones who really see it with their own eyes what is happening, and they maybe in some cases better understand, you know, what's in store for them. So that's something that was really one of the big lessons learned, in my mind, at least.
Thank you. And are they thinking about long-term effects, like what happens in 10 or 20 years from now?
Yeah, I would say so. I mean, obviously, it's very different between the group of stakeholders you're dealing with, and it's really important to be sure that you're including the right people, and the broadest group possible. But I would definitely say that is the case. Maybe, you know, less so with politicians, but at least you know. But then again, you know, it's been a few years, so that's something that's interesting to mention as well. It's been a few years since we did this, so maybe I can't, maybe you know, your head get lost in time during COVID, but I think it's about 2 years or maybe even 3 since these original analysis happened, and just so much has happened in the general discussion about climate change and the impact of climate change. So I'm sure that if we would do this now, the results would even be, you know, that the people really are thinking about this. So I think that has also changed a lot in the past, I don't know, 2 years or so.
Okay, thank you. I have 2 questions for Tarell then. One is, I think you kind of touched up on it, but does the snow crab adapt to changing climates? Is it adapting? And the other question is, would small marine protected areas within fishing zones prevent some of these dangers from occurring?
Yeah, thanks, Jonas. I was just writing down your questions there. On the idea of adapting, what we're seeing with it is, yeah, it is a fairly adaptive animal. So as I said, the amount of habitat on planet Earth right now is actually opening up, and it seems to occupy areas pretty quickly that are opening up. The Barents Sea is an obvious one, but right next door in the Kara Sea, as ice recedes and opens up for part of the year, it seems like it's moving in there as well. So yes, the snow crab is going to be fairly adaptive to movement, is my sense on it, and it will be a general northward movement from all angles into kind of the Arctic. On the idea of small MPAs, I read it there in the chat. I don't know the exact answer if small MPAs are going to stop effects of overharvesting. I think the snow crab works on big spatial scales. The biomass trends in our region are correlated more than they give credit, are given credit for. We just had a recent recovery phase happen right from stem to stern, from the south coast to the northeast coast at the same time. So I think macro management is more of an appropriate approach to snow crab, not to say that small scale MPAs are not going to have some effect, but my initial answer is I think macro scale management measures are the best option.
Thank you. Stein Arne, you said that we should work together, and we have small communities in the Northern Atlantic that are heavily affected, and of course we need to work together, but there's a lot of science, a lot of expertise that needs to be involved. So from your experience, how much do you feel that you're getting a backup from the governments, not just on municipality level, but rather on national level?
I think we are getting an increasing support that we need to work together on this, and we have a greater and greater understanding that the ocean is one piece that is extremely connected, and that we are all connected in the Northern Atlantic. And it is just to show all the implication that smaller changes in the Gulf Stream can have for all our communities. And the only thing that is certain with the future is that it will be more uncertain, and there will be more changes, and there will be more unexpected changes. And in order to deal with that and to increase the responsive capacity to take action when something unexpected happens, I think we need to work together, both the communities, research institutions, and the public in general, because these changes and the uncertainty is so great that we will not be able to solve this alone. But together, we will be able to get a better picture of that and to find better and faster solutions.
Yes, we can certainly see that countries are differently involved in dealing with this. And just to mention that it's impressive to see how much the UK has been doing, and Seafish has been doing wonderful work in developing adaptation plans. And at the same time, we see that countries like Iceland are miles behind them. And same goes for most of the Nordic countries. For example, there's not a lot of adaptation plans available for fisheries or aquaculture. But I don't think we have any more questions here, and we have about 5 minutes left. But if there are no other questions coming in, I'm wondering if we should just put an end to this session. Krista, is somebody gonna close the session?
I'm going to step in and say thank you very much for this very interesting session. First, I have to apologize for my mixing of bibliography. It was, of course, Jonas Widerson who moderated this session, and you did a great job. I hope no one died of this mixing, but we put it on the account for the embarrassing things. So this is how it is. I have got the job of doing some closing remarks before handing over to give Don McNeil some to end the conference. So I just want to take a short brief through the day, and today we have heard interesting and you can say optimistic speeches from the Minister of Fisheries and in Iceland and Norway, and that's of course things to take with us further. And we have also seen colorful lives in Newfoundland and North Norway on film. We also, from Jon Gardar Steingrimsson, we have heard about recessions in Iceland due to the decline in fishing, but also the huge growth related to research and development in the new bioeconomy developments, and who also creates new research and development-based businesses. Line Kjeldstrup in Biotech North has taught us how to commercialize products from the marine biotechnology sector, and you could say with a focus on value more than volume, and there is value in health, and the future is bright. Jason Woolley also followed up with the value chain positioning via market strategy and branding of their protein products, and he also pointed at the required research and development and also business structure required. These are the two things that also have to go hand in hand, and we must teach the market. And what is said, health aspects create a high market growth. So the future is bright also there. Heather Burke, the director of for Center of Aquaculture in Newfoundland, was talking about the bioproducts value chain based on snow crab, and as experienced by others, there are huge values in processing, I could say discharge, or what we earlier called waste. The second session today, the whale in the room and the climate strategy, was also a very interesting one, and something we have to follow very closely in the future. Glenn Nolan talked about the framework for climate services, the needs in different sectors, and also the need for easy and understandable picture of the development. Further, Daryl Maloney also talked about the snow crab and what affect the species, and if you say cold temperature in their early lives gives good catches later on, and that you could say the way the climate change is going, we could hope that also the catches in the future will be there. Furthermore, Ragnhild Fredriksdottir from Climefish was talking about climate change and how it affects marine life, change in fish stock size, growth rates, leading to decrease in maximum catch potential and complex quota negotiations. Also talking about the migration of fish stocks that are effective and that species are coming and going, and that can have negative impact on local communities, but also positive. Adaptations are necessary, and she's pointing directly at the climate adaptation plan. At the end, Sten Arne Rånes from Troms and Finnmark County, we have learned that coastal communities are in the front line of the climate change, and we need lighthouse projects. He was talking about the impetus that is a large Horizon Europe project, and that we say coastal and Arctic demonstrator that collaborate with communities, businesses, and region for better decision making. And he also said we must prepare to ride the storm, of course, related to the climate change. So that's something to take with us. And by that, I give the screen to Don McNeil, who will do some closing remarks. Don.
Hello, thank you, Niles. Hello, everybody. I'd like to extend a heartfelt thank you to everyone who logged on and attended over the past 3 days. We hope you found the presentations useful and stimulating. I'd also like to thank all the presenters and moderators for donating their time and for the exceptional job they did. Thank you very much. All 3 days of the Laurentic Forum 2021 were recorded and will be found on our website in the coming weeks. We will also be sending each of you a short survey, which we very much appreciate you completing so we can have your feedback and be able to improve on our future events. We take great pride in how this initiative has grown organically from the bottom up, starting with a simple act of commemoration for the loss of the 21 Newfoundlanders and 44 Irishmen who were among the 354 naval reservists who in 1917 were drowned in the sinking of the HSMS Laurentic at the mouth of Loch Swilly in County Donegal. This forum and conference is a fitting memorial to them all. We were just a small group of 8 friends back in 2006 when we laid our first wreath. But from that, we have started back then and has friends and supporters in Newfoundland, Labrador, North Norway, and Iceland, and of course, Ireland. Quality of the presentations you just heard were of high caliber, well presented, but just as striking was our natural connectiveness. And they were of direct relevance and importance to all 4 jurisdictions participating. None of this would have been possible without the same sustained buy-in support the forum has received from the community and local development agencies of my adopted home in County Donegal, and the continued support from my native home of Newfoundland and Labrador. This year is very special. We've now broadened our consortium to include North Norway and Iceland. We wish to acknowledge the very enthusiastic support of Ambassador Mari Skarai, Deputy Ambassador Arnie Folros, and their staff at the Norwegian Embassy in Ireland. With the embassy's help, we found important allies in the North Norway EU office in Brussels, whom today's chair, Niles Nilsson, is director of. And an additional special thanks to the Troms and Finnmark County Council, who sent Steinar Reins, Senior Economic Policy Advisor, who spoke on the climate change, to be on the ground in Donegal for the event. He's been with us here for the past week and is returning with an enlightened understanding of the commonalities of both of our regions. We hope you made as good an impression on him as he had as on us. Thank you very much, John Arnie. It was a pleasure to host you in Donegal, and we look forward to visiting you in Norway. I also like to acknowledge enthusiastic input and engagement from our new Icelandic friends at the Mathis Institute and the Icelandic Tourism Board. This year's conference has been digitally and technically organized by the Marine Institute Newfoundland and Labrador, with additional support from Hospitality Newfoundland and Labrador and digital mini hybrid events hosted in County Donegal by Údar's na Gaeltacht in Gweedore and Letterkenny Institute of Technology in Letterkenny. But with that said, the person behind the scenes, which has been working around the clock for the past few weeks, putting this all together, is Krista Sweetman, International Projects Officer at the Marine Institute in Newfoundland. Krista, thank you very, very much. And last but not least, I'd like to thank and acknowledge our funders and sponsors who helped make this event possible, without whom nothing would have happened. The principal core funding came from Minnesota Development Partnership through the EU Leader Program and the Irish National Marine Institute in Galway, along with additional sponsorship and supports from Údar's na Gaeltacht, BIM, Letterkenny Institute of Technology, IRNAC, Donegal County Council, Fáilte Ireland, Hospitality Newfoundland and Labrador, and the Government of Newfoundland and Labrador. With that, I bid you goodbye and hope to see you next year, hopefully in person at the Laurentic Forum 2022. Thank you very much.